Hello. What about if in a problem is given where you're given the graph and you have to find the original equation? So I have several problems here that are pretty fast. The drawings, you can see the drawings are pretty good. There's a template that is a plastic template that is perfect when you use the paper correctly. You know, this is 1 centimeter, and obviously this is 1 centimeter. When you use that, when you're doing this, you can get and you use the template. The template is made for different. There are different templates, and they're obviously made for different equations, and that's how you get this thing to really very pretty. Anyway, so let's start with one of them. We'll start with this one here. That, and then I'll do it in another paper. I use a different pen because I don't like that pen. Okay, so on this one we have, the problem will be, normally we'll say given the graph, find the original equation. In this case, we have the roots are -3 and 1. The minimum or the extrema, we'll call it the vertex, is at -1 and -4. The y crossing or the y-intercept is -3. So we'll say, I don't know how to say that, but y-intercept is equal to -3. That's enough for information to find the equation. Okay? Let me see. Okay, I don't want to be outside the camera. Okay, so from this is important, very important, because it tells us the C from here. We say the C is equal to -3. Okay. From the roots, we can get the rest of it. Well, we can start, actually, from the vertex, we can find the vertex form of the equation. I would say, let's see what happens. The vertex formula is y equal to ax minus h squared plus k. This is the standard form of the trinomial polynomial. So from here we can extract h, and you can see it's minus It's minus 1. In order to get a minus 1, then h has to be the opposite. I mean, let me see, let me double check here. Okay, let's substitute this. Yeah, so y should be equal to 8. Looks like it's 8 is 1, you know, so we can say that x looks like it's a 1. Then from here, the x value of the vertex is minus 1. That means that this should be plus h squared, and k is minus 4. So how do we find the original, the standard form? Well, we can multiply this thing. Oh, I wrote this wrong. H plus minus 1. Okay. So if we write this as this, we should find our equation. So x times x is x squared. X times 1 is x. Then we start with this one. 1 times x is x. And 1 times 1 is 1 squared, which is 1 minus 4. That looks good. That looks good. So the original equation should be minus 3 equal to y. That's it. So let's look at the equations here. I think it's here. You can see it there. It's right here. It's question B. And actually it says here, yeah, it's written right there. So that's how we go from the graph back to the equation. What about if we use the factor form? Like if we had, in order for the roots to be minus 3, then this has to be plus 3. And on this one, in order to be 1, then this one has to be minus 1. Okay, so let's see what happens if we can get it just from the roots. So x times x is x squared. X times minus 1 is minus x. 3 times x is plus 3x. And 3 times minus 1 is minus 3. And so this equation should be equal to plus 2x minus 3. So we found it's much faster using the roots. You can find the equation very fast. Okay. So that's how you go back to the equation. Now we only have 9 minutes, so we can do another one. So we'll do this one here. Okay, so in that one we have one root is at 1, so we'll use the roots. The roots is 1 and 5, both positive. So let's do the using the roots method. Okay, so we write x minus 1 and x minus 5 is equal to 0. That implies we multiply x times x, x squared, x times 5 times minus 5 is minus 5x, minus x, minus 1 times x is minus x, and minus 1 times minus 5 is 5 positive. This implies that this is x squared, this should be minus 6x, and the 5. Very fast. So when we look at this, there it is. X squared minus 6x plus 5. So we do another one. Let's take this one. And you can see that there's a lot of information, you know, we have the y crossing, but by just using the roots, we can find them, you know. So this one is minus 1 so the roots are minus 1, let me see, minus 1 and plus 5, minus 1 and plus 5. Okay, so let's see what that means. This implies that the equation, I should write that also here, the equation. Okay, so the equation should be x plus 1 and x minus 5. That implies x times x is x squared, x times minus 5 is minus 5x, 1 times x is x, and 1 times minus 5 is minus 5. That implies that the formula should be, the standard form of the equation should be x squared minus 4x minus 5. And if we look at the thing, there it is. X squared minus 4x minus 5. Yeah, x squared minus 4x minus 5. 14-minute video. We can do another one. We should find a complicated thing with a twist, you know. But let's see. This one look good here. Let's see what happens here. Let's take this one here. where the roots are -3 and 2. Roots are -3. See, my hands and my brains are not connecting. You know, it's like my brain say one thing, my mouth says another thing, and my pen and my hands write something else. That's a perfect combination. Okay, so -3 and 2. Okay, so that implies that y should be equal to x plus 3 and x minus 2. And so that implies x times x is x squared. X times -2 is -2x. 3 times x is plus 3x. And 3 times -2 is -6x. -6, I'm sorry. This is equal to 0. That implies that the original standard form of the trinomial polynomial should be 1x plus x minus 6. No twist really. I was expecting a twist, but no twist whatsoever. Yeah, that's correct. That's the formula right there. Yeah. Like in here. So, damn, you know, what the hell? I want to find something difficult, man. Okay, but in any case, I guess you get the idea. I hope you like this video. Don't forget to subscribe. Give me a like or a dislike. Put some comments down, and I'll see you on the next video. Thanks so much. Bye-bye.